Alright, welcome to Ottinger's online class. We got section 8.4 today. I'm going to try to go as fast as I can. Let's just do this. Section 8.4, it's on natural logs. And I think in chapter 7 I know we did the continuous interest formulas, and you see the base E exponential function on page 419. Well, natural log, which is ln x, is the inverse of base e, so that gives us natural logs. You can see some examples of, kind of how they get this. We have the function e to the x, and if we take log and make it base e, that is the same thing as having a natural log. So natural log is just a logarithmic function to the base of e, okay? And so sort of like common logs, we won't write the base e, they're just going to write natural logs. You have, and I don't have a calculator on this computer, but when it gets time, I'll show you how to put it, or try to explain to you how to put it in your calculator. You should be able to find it. So other than that, we're just going to jump straight to the homework and do this. Problems 1 through 15, they are set up as equations, although they don't really want you to solve them, but they want you to switch forms. But switching forms is easier done kind of like you are solving it. So to do number one, I'm going to apply, and again, because these functions are inverses, you can do this, but I'm going to apply ln to both sides, okay? And inverse functions undo each other, okay? Handwriting is kind of bad, but that's an ln on both sides. So ln e to the 15, ln x, they cancel, and this gives me 15 to the ln x, okay? That's that's going from exponential form to natural log form. Same thing. Are any of these any different? They're gonna work a little bit different, but that's basically it. Number 3, ln to both sides, natural log and base e undo each other, and the answer is negative 5x equals ln 0.2. Okay. Looking at some of these others, I guess I should do number 7. ln. And since that's an expression, I'm going to put that one in parentheses. ln and e goes away, and so I have 4 equals ln to the x minus 3. These are not really solvable. We're going to do some solving equations in a minute, but that's basically it on that section. Same thing, now we're in natural log form, so we're going to convert it to base e. And so the only thing is these are going to look a little different when I do something to the exponential, to the base e. The whatever I do it to is in the exponent. These right here, same thing, they undo each other, so 36. But when I read this answer to you out of the book, the answer is equal to e to the power of 2x. That would be the only thing that would be kind of different there. Let me look at all of these. Jump down and do 17. E to both sides, they undo each other, and 15 is equal to e to the power of x. And this kind of switching forms just kind of gets you set up to be able to solve, which I really wish the next homework problems were 29 and 31, but the next set of homework problems are 19 through 27, where if you read the directions, it says express as a single log. We can do that, and we're going to use our properties that we learned. I don't remember what section, but we have our product property, our quotient property, and our power property, and I'm going to use those. And just in class yesterday, it sounded like some of you didn't quite remember some of those. So like, number 19, if I have a number out front, I can move it to the power, right? And so using my power property, ln 3 to the third minus ln 9. 3 to the third is 27. By the way, I would view these problems as non-calculator. I got to throw that out there. And then to write it as a single log, because there's a subtraction there, I can say ln 27 divided by 9. And now I have written it out as a single log, but 27 divided by 9 is 3. So ln 3 is the answer there. Jumping to 21, same problem. I'm going to go a little faster, I guess. Ln x squared plus ln 4 squared using that power property. Let's see, that's just 16. And since I have a plus, I'm not going to divide them. I'm going to multiply them. And, I could say x squared times 16, but, we always write the coefficient first. So 16x squared. 23. Going to use my, and these kind of get redundant. I don't know. And again, I think most of them are easy enough without a calculator. I guess 20 looks a little nasty. 22. Oh man, the even ones, you got your work cut out for you. Evidently, I got the easier ones doing odd. All right, 23. I'm going to use my power property and I'm just going to jump straight to 25. All right, 5 squared is 25, and then ln 125 divided by 25. That's just going to be 5. All right, now moving on to the bread and butter. I'm going to do. I think I'm going to go off the worksheet because those are at the bottom. I'm still going to work them. But I'm going to just write them down because now we're solving. And this is kind of, it's kind of more important. Something you definitely need to be able to do. Thinking about these, you are going to need your calculator for these because and this computer that I'm working on doesn't have a calculator. But I'll say first, we're going to use our equation solving skills. E is, or x is, this is an exponential equation, I guess I could say easier. And to solve it, the first thing I'm going to do to get to x is I'm going to isolate it. So I'm going to subtract 3. And I'm going to leave those steps out because you all should be good enough. And then I'm going to divide 5. And I get e to the x equals 3. Now, this is not a problem where I can do a like base. But on those conversions, you kind of saw how we got rid of e. We apply ln to both sides. Okay? ln and en do each other. So my answer is x equals ln 3. Now, to get a decimal approximation for that, you do have an ln button on your calculator. You also have an e to the x button to the calculator. And all that is to the left of 4. So natural log, and you can just type in ln 3, hit enter, and you have your decimal answer. I feel like these are pretty basic. Let's go ahead and do number 31. 31 is already set up where the e is isolated. So we really shouldn't have to do 31, but let's just do it. Apply its inverse to both sides, and x equals ln 5.8. And to get the answer that the book wants, ln 5.8 in your calculator. Number 33. Subtract 4. And then same thing. I think you're probably, hopefully, catching on. So answer is ln 15. These obviously can get more difficult. We need to go to the next page and do some problems. They do get a little bit more difficult. Like if you look at 35, the ln, this time it's not an exponential, it's a logarithmic, but we're going to do the same thing. Now I will say, because this x plus 2 is in parentheses bonded by the natural log, the natural log is isolated. So we're going to do the exponential e, and these undo each other, and I'll be left with x plus 2 equals e to the 3, and my answer is x equals e to the 3 minus 2, which you can still get a decimal approximation for, because in your calculator you can hit second ln, do it to the 3 power, subtract 2 from it, and you'll have your decimal answer. 37. 37's a good one. 37's a good one, and I guess I should write the whole problem down, because before we can inverse ln, I have 2 natural logs. And so I need to write it as a single natural log. And using those properties again, which was what that one section was kind of about, I'm going to say ln 3x times 2x equals 9, which I really wanted to say it's 6x squared equals 9. Now, might be confusing to some, like in the earlier problems, like what did I subtract, what did I divide first, and I was trying to isolate it, and it might be hard to tell for you, but like this is ln 6x squared, so we won't divide by 6 or square first. We need to get rid of the ln, and now we have 6x squared equals e9, and now we can finish it. But of course, you're going to have to divide by 6, and you're going to have to square root. So this is going to be e9, and you can do it all together. I know Trey likes to do it all together, or you can do it separate. E9 divided by 6, or even just e9, get an answer, divided by 6, get an answer, square root, get an answer, and you're kind of good to go. I do want to do 2 more problems. We haven't done much word problems, but I like the word problems in this section. I'm going to do problems 41 and probably 43 on the next page, and then I can shut it down. Several ways to get the answers here, but this is a formula we used in the last chapter, right? Continuous exponential. Let me read this real quick. I think that you could answer 41 essentially without me really teaching you anything about it, but this is 750, and we are depositing this yet. Yes, okay. E to the 0.027, and we can put a t here or an x or whatever, depending on what we're doing. So, should be pretty simple. To answer A, we're just going to put 3 here and hit enter. What do they want in B? How long will it take her account to reach $2,000? Before this chapter, the only way you would have known to have done this problem is to put this problem in y equals and see when it got to 2,000, and that would be it's really probably an approximation. But now that you can solve, we can put 2,000 in for A, and we can solve it for this variable now. We can divide by 750. I'm just going to do it. Use my handheld calculator. That's 2.6 repeating. I'm not going to round in my calculator, but I have to round here. And now that we know how to do this, we can ln both sides and get rid of that. Let's see what ln 2.6 is, or 2.6 repeating. This is about 0.43 equals 0.027x, and now I can divide that by 0.027, and it appears that we'd have to look at what the answer says in the book, but right at 16 years is how long it's going to take to get to $2,000. Let's see, part C, what's it want? She wants to have at least $1,000 in her account after 5 years. Ooh, that's a good one. And so to do this, she wants to have $1,000. We don't know the initial amount, same interest rate for 5 years, and I guess it's not that hard. There should be an equal sign there. And so, really to get your answer, all you have to do is 1,000 divided by all this junk right here, and you've got it. I feel like that's a good easy word problem. Problem number 43 is, again, something that we've done before, but now it's with logarithmic. So this one, again, I don't have my calculator to show you, but you should be able to do it. You're going to put it in stat like you've done. The only difference is it's a logarithmic regression, and you are going to use when you write your equation, because you're going to put this in L1, this in L2. I showed you how to even store it. I don't know why your Algebra 1 teachers wouldn't let you store it, but you're going to do an LN regression for natural log regression on this. And the problem should say to find a logarithmic function to model the data. So the only difference is, what test was this on? Was this on the last test? You're going to do a natural log regression that we're going to add here. So then once you have that equation, you can predict it for 30 years. You should be able to do that. If not, I can show you when I come back. That is the lesson. So let me get this on, and you'll be good to go.